Myself, Tahira Mazumdar. I'm from IT department at Ajay Garg Engineering College, and today I'll be talking about the topic object orientation concept, which comes under the subject object oriented system design, with subject code KCS 054 under AKTU. To start with, the contents on which I'll be talking about, I'll be first giving a brief introduction to the concept of modeling. Then I'll talk about the importance of modeling, the purpose of modeling, why do we go for object-oriented concepts, what are the issues involved in object-oriented concepts, and the principles related to object-oriented methodology. To start with, first, let us discuss what exactly do we mean by modeling. Now, by model, basically, let us define what exactly a model is. A model is basically an abstraction. It is a building block, or rather we can say it is a prototype of a system that we want to develop. The main purpose of a model is for understanding the actual system. So model is basically a replica of the original or the actual system. Rather, we can say it is a simplification of our perception of reality. What the reality is, we try to make a mini version of that reality and try to understand that particular concept related to reality. So, and in that, another point is that if that particular thing which you are trying to model, if it exists, fine, and if it doesn't exist, that means we are working on an illusion and we are trying to see the feasibility of that particular concept. An example, for example, we want to make a bridge. So before we start with the bridge, we make a miniature bridge and see the feasibility of actually making the bridge by seeing the how the miniature bridge functions. So we have normally designers, they build different kinds of models for various purposes before constructing the thing, that is to have a fair understanding of how the system will go about. I'll take up more on that. Now, for example, we have like cars, airplanes, and so on. If you want to go for making these models, what we do is that initially we take blueprints of these parts and then we proceed. Models are used for serving various kinds of purpose. These are examples of real life modeling. For example, we want to build a house. So what we do is that we make a miniature model of the actual house. This is a miniature version, and then we try to conceptualize, or we try to visualize what are the aspects which needs to be considered more in detail, what are the aspects which needs to be ignored, and where some lacunas might be there. This is another example of modeling where we have a blueprint of a car that we want to go about to actually make it in the real world. This is an example of another modeling. Fine, a real world example of modeling. Now the next point which we are talking about is what is the importance of modeling? Why do we go for the concept of modeling? This entire subject which I'm talking about, object-oriented concepts or object-oriented analysis and designing, it starts with modeling concepts and then it goes further. So to start with, first let us talk about why do we go for modeling. The main point about modeling is that modeling, it is not the actual system, but it is a blueprint of the actual system. So what we do, if we want to understand the actual system, we focus on the blueprint and we try to understand how exactly the blueprint will react. And based on that, we will try to optimize, or we try to work further on our actual system. Models helps us to visualize a system as it is or as we want it to be. It helps us to specify the structure or behavior of the system, and it helps us to do this. It does so by providing a template that will guide us in constructing the system. Now, from a software point of view, what is modeling? Because our focus is in software, so modeling, basically through modeling, we try to understand why exactly a software system is needed, what it should do, and how it should do. So basically, we want to make a software. We want to make a software which will work in the real world scenario. Before that, we try to make a model of the system. Not by model here. By model here, we don't mean the physical model like the previous example which we have said. Here, this is a mini version of a car which is physically constructed, a small mini version. But when it comes to software, by modeling, what we said, we don't construct a physical mini version, but we normally go for graphical. By modeling, we normally go for going for a graphical representation. We go for a graphical view of the software that we want to make, of the final end software that we want to make. And why so? So that it helps us to understand why the software is needed, what the software will be doing, and how it should be functioning. Now, once we have the graphical view of the system that we want to construct, it helps us to communicate our understanding of why the software is needed, what purpose the software will serve, and how exactly do we go about making the software system. Now, we also go for modeling to detect the commonalities and the differences in the perception of different people who are working on that particular who tend to work on the particular software system, like perception of my perception, the other person's perception, his perception, and the other people, various people who are involved in that particular making of the software system. So modeling helps us to identify the commonalities and the differences. It also helps to detect misunderstandings, miscommunications, and other lacunas that we might actually tend to have before we actually make the system. So modeling helps us to get a brief idea about the system that we want to actually go about to make. Now, what is the purpose of modeling? It basically helps us to test a physical entity before building a system. That is kind of simulation, we can say, because once a model of the system is ready, it helps us to communicate with the customer. By this point, what we are saying is that, again, I'm saying from software point of view, by modeling, we mean to say a graphical view of the system, of the functionality of the system that we are going to, will be achieving subsequently. So once we have the model, we can communicate with the customer or the client, or rather the client who want that particular software, because once through model, the customer can also, it becomes easy for the customer to communicate with the developers what exactly the requirement of the software system should be. Because as I told you, when you are talking about modeling as far as software is concerned, we tend to go for graphical view. Now, in that aspect, so once we are visualizing a system through modeling, we go for visualizing a system. And if we are visualizing a system, what happens is that we tend to understand the system in a much better perspective, in a much better way. Of course, it helps because of that. It helps in reduction of complexity. It helps in better understanding of the problem, and there are so many other advantages as well, which are the advantages served by the concept of modeling. Now, as I have taught, this subject basically deals with object-oriented modeling. So right now I have talked about what modeling is. Now I'll be talking about what objects are. What do you mean by objects? Now, an object basically is an instance, or rather is an entity which has got existence. Now, what kind of existence do we say? An object has state and behavior. Now, by state, we are saying about the descriptive characteristics that are involved with respect to that object. And by behavior, we mean to say what that particular object can do or what can be done. Now, another point that I want to talk about when you're talking about object, what exactly do we, how do we visualize that? See, when we are talking about real world scenario, when you're talking of an object, for example, this is an object, pen. It has got a physical existence. It has got some characteristics, like what are the, when you're talking about an object pen, for example, this is a pen. What are the characteristics? I'll say that it is of a shape, like a cylindrical shape, having a silver color body. These are the characteristics of this object. The behavior, what does this object do? It is used for writing, it is used for writing on it on paper. It is used for serving purposes like conveying some your thoughts to written lines. Now, this is with respect to physical perception. Now, with respect to software perception, with respect to perception related to software, with respect to software, what are objects? When you're talking about objects with respect to software, it means any entity, we can say any entity which has existence. Now, what do you mean by having existence? Meaning, when you're talking from software world point of view, having existence means being stored in memory. That means objects having existence means objects that are created and that are stored in certain memory location. That is what we mean by objects in terms from software point of view. So like as I said about this pen, this characteristics is how it looks like. In from this pen's point of view, it is cylindrical, the color and so on. The behavior is what it does. Like we can take some other example, like for example, let us take a bank account, the statement of a bank account. Now what does it include? It includes the account number and its current balance. Now here what we have the character, we have like as I said, the state, the characteristics. So with respect to account number, what are the characteristics we have with respect to a bank account? I mean to say, the characteristics are the account number, the balance, the date of withdrawal, the date of deposit, and so on. These are the characteristics. And the behavior is the ability to make deposits and withdrawals. So this is an example of an object, we can say. Now we need to note that the behavior of an object might change its state. Like for example, if we are talking about current balance, this is a state of a bank account. If you withdraw money from the bank account, the current balance will change, it will get reduced. So whatever behavior we perform on an object, the behavior tends to changing of the state of the object. Now, as I told you, when you're talking about object, our focus is not on real life objects which has got unique physical existence, like for example, this remote or this pen. Our focus is on software objects. Now, physical objects have got real world existence. You can touch them, you can feel them, you can see them. But when it comes to software objects related to software world, they don't have physical existence. Now, how do we visualize that? By objects related to software world, we mean objects which has identity. In what concept? That means they are being created, objects which are created and stored in memory, and that memory can be RAM, it can be hard disk, it can be any storage unit. Fine. Now let us come to some examples of software objects which are having abstract concepts. Like for example, we have this dog, bicycle, bank account. From now on, whenever we are using this term object, we are not meaning those objects which are having unique physical existence, but we are talking about software objects which have got unique which are being created and which have got unique memory location where it is being stored. Now, for example, when you're talking about objects like real objects like this units, dogs, bicycles and all, what do their state mean? Every object, be it real world objects or be it software objects, every object has got two important characteristics. We refer to them as the state and as the behavior, as I told in the previous slide. By dog, what are the state? That means what are the characteristics of a dog? We talk, it has got different unique name. Every dog have got unique name. For example, they are of different color, they can be of different breed, and they can be of different state of hunger. For example, when you're talking about bicycle state, what can it be? It can be the color of the bicycle, it can be whether that particular bicycle has gear or not, it can be the brand, it can be the price. These are the state of the bicycle. Similarly, when you're talking about behavior of a dog, behavior means the activities involved. It can do bark, it can fetch, it can run, it can do whatever activities that the dog can do. Similarly, from bicycle's point of view, we can say you can cycle the bicycle, you can put a brake on the bicycle, you can keep it standing for some time and so on. So these are the properties whenever we talk about object, we talk about state and behavior of an object, and that concerns not only real world object but also software object. So if you take some examples of objects, we can say, as an instructor myself, because I've got an existence, so I'm an object from real world scenario, and from virtual scenario I'll be an object if my state and my behavior is being recorded in a storage medium, then my characteristics, or rather my object, will be created. Similarly, you as a student, this room, this university, and so on. So objects have unique existence. So all we can say they have identity. Objects and objects have identity. They contain, objects can contain other data types which are called as attributes, and the operations which are performed on the objects, we call them as operations or methods, technically speaking. And when you're talking about every object, as I said, every object has got three important responsibilities. What is the characteristics about the object, or other way, as I said, state, which are technically referred to as attributes. What do that particular object do, which are technically referred to as operations, or also called as methods. And how they know about other objects, that is, how do they relate to other objects, which we technically call them as relationships. Fine. Now, this features of an object, the attributes and the associated values are normally hidden inside the object, and it is not visible to us, to other objects of from beyond that object, we can say like that. So if an object wants to change a value associated with it with other objects, like for example, we have object 1, we have object 2, we have object 3. Let us say we have 3 objects. Every object will have their own state and behavior, which we also call as operations. Every object will have their own state and behavior, which we are also calling it as operations. And for example, a particular object 1, object 2, object 3, let us say object 1 wants to make some modification on object 2, then it does so by a message passing technique. That means by sending a message from one object to the other object. This is a graphical visualization of how exactly an object feature looks like. Let us say this is, we are trying to visualize an object, woman, for example. So first, as I told you, it has got some three important characteristics. One is the attribute that refers to the state, if you remember. So what are the attributes that are distinct with respect to an woman? We'll say the age, her salary, her name, and so on. So we are talking about two attributes here right now, age and salary. These attributes have values. What are the values of these attributes? The age of the woman is 35, her salary is, let us say, 10K. Fine. Now this is related to attributes. Next is, what are the operations that can be performed on this particular object? So operations, like what are the operations? It can be, you can ask, someone can ask, what is your age? So getting an woman to tell her what is her age, getting a woman to, for example, that is from what? That is from, for example, a friend who is another object, can ask the woman what is your age, and she can give a response with respect to that query. For example, her employer can set her salary. Her salary is 10, employer can give a hike and make it 20. So this are basically what? These are basically the methods or the operations that are performed on this object. So object have got this distinct characteristics, methods, and attributes. Now, what is object orientation all about? Our next topic is, as we talked about modeling, we know what are objects. Now, what exactly object orientation deal with? As the name indicate, object orientation, of course, works on objects. And our orientation, by orientation means we need to think in line of abstraction and encapsulation. Fine. Now, what is abstraction and what is encapsulation? These two terms are the building blocks as far as object orientation concept is concerned. Now, by abstraction, we mean to say that we are focusing on the essential, and we are omitting, we are not concerned about the finer details. The finer details are not being looked into. That means the focus is more on what an object does. We don't look into the how part. That part is ignored. So by abstraction, when you're talking about abstraction, the focus is on the essential functionality or on the essential look of the object, and the finer details are hidden. By encapsulation, what exactly do we refer to. By encapsulation, we are referring to the concept of information hiding. That means every object, whatever are its attributes, whatever are its methods, as I told you, every object has got distinct two important characteristics, the attributes and the methods. So all of this are this particular characteristics are very much internal to the object, and other objects cannot see that. And this is the property which we call it as encapsulation. So by encapsulation, every object has the property of hiding the information related to the object, such as by what are the property, like attributes and methods. So objects tend to encapsulate the property. The behavior is a collection of methods and messages. So if you look at this figure, for example, this I'm just talking about encapsulation, and the figure on the right is with respect to abstraction, and the figure on the left is with respect to encapsulation. Now, abstraction, as I told you, is the focus is on essential. The focus is on the essential features, and the finer details is being ignored. So here, and that this essential features is basically it varies from person to person. It's perception dependent. Like for example, we are talking of it's cat. This is a cat. Fine. By abstraction, for example, we are looking from its face point of view. This is how the face looks. By this, let us say there is a lady who is perceiving how a cat is. Another lady perceiving a cat with respect to her skeletal lookup. So this the figure on the right is with respect to abstraction. As far as perception, the perception varies from person to person, but the focus is on the essential features, and we tend to ignore the finer details. When you're talking about encapsulation hides the implementation part. What exactly goes into the making, that is hidden. The outer view, or how the functionality is being taken care of. Like we are talking about this cat. This is a cat, and this is how it looks like. What exactly is inside it, how the cat gets to do whatever it is doing, that is being hidden. So this feature is called as encapsulation, and this feature of abstraction and encapsulation are the two building blocks as far as object-oriented modeling is concerned. Now, if you take an example, what is object orientation? Let us take an example. Let us take an example of car, for example. So if you just look at it, these are objects. These are objects. Why objects? Because they have existence, and they are unique. Now, as again saying from existence point of view, not from software world point of view, we are not talking about the physical existence, but we are talking about their data being stored in a storage medium. And data related to what? Related to the attributes of these objects, related to the operations that these objects can perform. Now, when you're talking about the attributes, as far as these objects are concerned, when you're talking about attributes, so we are talking about, for example, when you're talking about these models of car, what are the characteristics that are being recorded or that are noted with respect to this objects? The model of the car, the location, where the car is right now, for example, the number of wheels, and we can go on as per our requirement, like what is the date of purchase of the car, what is the price of the car. These are all related to the attributes of the car. Now, next is what this car can do. What are the operations this car can perform? The car can start, we can accelerate the car, we can add some more. That is as per the requirement of the software. We can perform brake on the car, right, and so on. So this entire data, if you're storing with respect to one, for example, object 1, then that object 1 is created. Object 2, if you're storing this data for this particular thing, then we'll say this is object 2. Object 2 is being created and instantiated. Now, so we can say, how exactly do we define object-oriented modeling? We can say it is a way of thinking about problems using models organized around real-world objects. So the focus is on the real world, and we try to visualize the real world. We make a model of the real world, and our thinking is based on how the real world functions, and based on that we try to convert it to our software world. The fundamental construct is the object, which combines both data and the behavior. So as I told you, what is an object? An object is anything which has got unique identity. It is basically anything which a concept applies, that are things thrown from the problem domain or solution space. So we can say these are all examples of objects. So objects, we can say they are structures that have identity and properties and behavior, and they are basically an instance of a active concept called class. This is a point which we'll be more looking into as we proceed in subsequent slides. It means, for example, let us say this is an object, fine. This is an object. What object? Let us say a girl. Let us say her name is Geeta. This is an object, girl. Now she is an instance. She is an instance, fine, of a collection. What is a collection? The collection is of, let us say, woman. So Geeta is an instance of a collection of objects of similar type, woman. So Geeta is an object, girl, and this is your class. Similarly, for the same concept will apply to other objects. Now, what is the difference basically of what we have learned so far and what exactly new comes in object-oriented perspective? The difference is that whatever we have learned before object-oriented, that is from an algorithmic perspective, in that case, the focus is more on procedures and functions, that is from structural programming point of view. We focus on the control structures, the decomposition of a larger algorithm into smaller ones. That is what we have done prior to object-oriented concept. In case of object-oriented perspective, the focus is on looking into objects as the main building block, on focusing on the objects as a main building block, and then working on objects. And what are objects? They are models of real world objects, fine, from software object. Now, when you're talking about object-oriented application, we are talking about object-oriented software. It is basically, again, when you're talking about object-oriented software, we're talking it as a collection of discrete objects which are interacting with each other. These objects, as I told you, they have property and behavior. Property, if you remember, we called it as attribute, and behavior is also called as methods, fine. And these objects interact among each other through messages, fine. This is something like this. We have an object 1, object 2, object 3, and we have this attribute or behavior, and these are your methods or operations, and objects interact among each other through messages, and all of this can be implemented through software also. Now, the focus right now, we are not focusing on how do we actually implement the objects from programming point of view. The focus is on understanding the theoretical concepts as far as the first unit of this particular subject is concerned. So we are now focusing on what exactly are involved, what exactly goes into the principles of object-oriented development. That is, we can say when you're talking about object-oriented analysis and design, when you're working on objects, what are the main principles that goes into the making of an object-oriented software system. This is something important principles involved: the identity, classification, inheritance, modularity, abstraction, encapsulation, polymorphism. Fine. Now, to start with, let us discuss about the identity. What do you mean by identity when you're talking about it as a principle that involves object-oriented concept? Identity means data is organized into discrete, distinguishable entities called objects. That means each object has got a unique identity. Each object has got an unique identity. Though, like for example, we are talking about personal computers, we are talking about laptops, we are talking about bicycles. They are objects, and when you're talking about each object in a particular object, each object is unique or different from another object, maybe of the same class or different class. The objects can be concrete, such as a file in a file system, or it can be a conceptual object, that means which does not have a physical existence. We can't see it, but it is very much there working in a software world. Like for example, a scheduling policy in a multiprocessor operating system. Each object, they have their own inherent identity. That is what makes it distinct and unique. And this is the important feature that goes that we're talking about as an important principle of object-oriented concepts. The punchline is that no two objects, even if they are of the same type, like you have multiple files, but still no two objects will be same. They are distinct and different from each other, even if all their attributes and values are same. Still then, the objects are unique. Each object is unique, will have its own existence, and they are different from another one. This is the first principle. So as I told you, an object has a state, it has a behavior, it has an identity. Like for example, we are talking about hammer. If you see, we have multiple thousands of hammers, but still among this multiple thousands of our hammer, each object is unique. We can identify each object from a huge collection of objects of the same type. Each object have got a state like how does it look like, what is it made, does it have a wooden handle, and so on, and what is the behavior of the object, what exactly does this object perform. Now when you're talking about hammer, it is about hitting on a nail. So this is the behavior. So these are the characteristics we can say related to an object. The next principle involved is classification. Now it means that though objects with the same data structures and behaviors, they can be grouped into a class. Like for example, we have a pen, we have another pen, 5-6 pens. All of them belong to the same category of objects, right? What is the category? They belong to pen, but the pen might be different. One might be of Renault, the other one might be of Parker, and so on. So when you're grouping similar objects into a particular category collection, we call it as a class, and this is an important property of object-oriented methodology, which we call it as classification. Each object, basically, it is said to be an instance of a class. That is, as I told you, you have a collection of pens, as I told you, multiple pens, but when you're taking one particular pen, that is an object which is an instance of that particular class. A class is basically is simply a representation of a type of object. And as I told you, a class is the blueprint from which the individual object can be created. So our focus, so first we identify the object, then what we do, once we identify the object, then we tend to group similar objects with the same property together, and we call them as class, and then we focus on class. So this, if you see, all of these objects are having similar characteristics. They are having 4 wheels, they are having the similar kind of body, and most of the characteristics are same. So we group all of these objects under a common class, and we call them as car. So you can have object, this is car 1, car 2, car 3. So car 1, car 2, car 3, they are objects, and this car is your class. So when you're putting all the objects of the same class together and then working on their characteristics, we call it as class. So moving further from objects, we are now moving to classes. Class have attributes, class have operations. So basically, if we want to define a class, we can say it is a collection of objects that share common properties, attributes, behaviors, and semantics in general. We can say this collection of objects have the same data structure and the behavior also in the solution space. Why? So because they are grouping similar types together. Hence, all the objects of the same class will be having the same characteristics. So hence, we'll use the same data structure. So what is classification? We can say classification basically refers to grouping of common objects into classes, and in the instance of a class, we call it as an object. So the act of creating an instance, we call it as an instantiation, and this act of creating an instance leads to the creation of an object. And all of this can very much be done through in the programming world by using so object-oriented programming languages like Python, Java, C++, and so on. This is an example of a class. Fine. So we have, this is what the class name, this is the attribute, this is the attribute, this is the name of the class, this is the operation that can be performed on the class. Now, so when you're talking about, this is a case of an account. Fine. Bank account, the class name is account. The attributes, every bank account will have an owner, will have an amount that is being deposited. As per our requirement, we will increase or decrease the number of attributes as per our programming requirement. The operations can be, you can suspend a bank account, you can deposit money in the bank account, you can withdraw, you can take a printout of the account, and so on. Whatever you will be including in this particular class, the attributes and operations that you will be including will be purely dependent on the software world that you're trying to model, the problem that you're trying to solve. So if you see, as I said, we have this is a figure which shows the relationship between classes and objects. We have class and we have 3 objects. If you see, we have object 1, object 2, object 3. All of these 3 objects come under, they are having similar characteristics, and we are putting them under the same category of class. Fine. So as I told you, as I told you. So object, the first one is the account name is Ivan account, the owner's name is ABC, and the amount stored is 5,000. The second object, the account name is Peter, the owner's name is XYZ, and this is the amount. And similarly, the third account is Kirill, the account with owner name is CSC, and this is the amount. So every object is basically an instance of a class, that is, it has got unique existence with values assigned to the attributes, and every object of this class in these operations can be performed. Operations like suspend, deposit, and withdraw can be performed on every object of this particular class. Here we are taking 3 objects, so on these 3 objects, these operations will be performed. So the next principle which I'm talking about is inheritance. What is inheritance? It is basically sharing of attributes and operations among the classes based on a hierarchical relationship. Here we have this subclasses that can be formed from a broadly defined class, and each subclass incorporates, so inherits all the properties of a superclass, and also add some more features to it. Like for example, if you take up this case, we have a class, let us say tree. Now when you're talking about tree, so let us take about class. This is the class name. This we have species, height, age, gross, reset, for example. These are the names of the attributes of this particular class tree. So we've got a class tree. Now when you're talking about inheritance, inheritance is a property, or rather we can say inheritance is a basic, very important principle of object-oriented concept, where we can come up with new classes from an existing class. So here the new class, we have a parent class, or we call it as superclass. The parent class is also called as superclass. It is also called as parent class. Now we can create new classes, let us say coniferous trees and deciduous trees, which have some extra features like reset and drop leaves. In addition, and these classes are inheriting from the class tree. Inheriting means whatever this class, whatever features tree was having, the base class tree is having, this class will have all of the features concerning tree. In addition to that, it will have some extra features. Similarly for deciduous trees. So this is a very, very important property of object-oriented concepts, and this goes into the making of large, good, important, complex software system. So here, as it is being said here, each class, subclass, they inherit the properties of its superclass. So each of this class will inherit whatever is there in the subclass, superclass, and they will come up with a new class. This is an example of another inheritance class. We have a base class vehicle, and these are the classes. So vehicle is the base class, and from this base class, we are creating some. This is our superclass. A class which is there, vehicle has got its own identity, vehicle has got its attributes and operations. Now using this as a base class, we can create two more superclasses, let us say land, water, and air. These are the subclasses in the sense, and when you're talking about inheritance, these subclasses they inherit all of the features of the base class or the superclass. In addition, they will have some extra features. Similarly, now when you're talking about car, now car is another class, it is another subclass which is inheriting the properties of another superclass land, and which is again inheriting from vehicle. Similarly, bus, here ship and boat, they inherit from which superclass water, which inherits from vehicle. Similarly, the other side. So this is a very important property which goes into the making of complex software system which are based on object-oriented concepts. Now, when you're talking about inheritance, we have multiple types of inheritance, like single inheritance, multiple, hybrid, multi-level, hierarchical, and so on. When you're talking about single inheritance, we have one level. You have a subclass inheriting from a superclass. Multiple, here we have one subclass inheriting from two superclass, from two base class. And hybrid, where we can have combination. If you see, we can have a combination. When you're talking about hybrid, class, so we have what? This is a hierarchical why hybrid. Let me first explain. Before I explain hybrid, let me first explain what exactly hierarchical is. Hierarchical looks like a tree-like pattern. You have one base class or superclass, and you have multiple subclasses. Multi-level is you have multiple level of inheritance, and from animal, mammal is inheriting, from mammal, human is being inherited. These are all subclasses which are in human subclass inherits from mammal, mammal subclass inherits from animal. And hybrid inheritance, you can have combination of all of this into one. Like for example, this part refers to hybrid inheritance, and this part refers to multiple inheritance, right? Now, let us talk about the next principle, modularity. Modularity, it is the process of decomposing a problem into a set of modules so as to reduce the overall complexity. It is a property where it is basically where it is a property of where a system can be decomposed into a set of cohesive and strongly cohesive and loosely coupled modules. We can see it as like this. For example, we are talking about a course registration system. If you look at a course registration system, it involves billing, it involves course catalog, and it involves a students management system. So if you're wanting to handle a course registration system, we break it up into three modules: billing system, the course registration system, and the student management system. So we are having three number of modules. So to understand this larger system, we basically focus on the three module system. We try to visualize this three module system, try to look more into it, try to conceptualize, try to implement, and then finally lead to the making of the bigger system. This is called modularity, that is breaking of a problem into smaller problem and focusing on the smaller problem and making them being realized. So we can say, and the basic for decomposition when you're talking about modularity is cohesion and coupling. Cohesion is the interconnection between a module. We can say it is the functional relatedness of the entities within a module. So cohesion needs to be high. And what is coupling? It is the interdependency between the modules. So for a very good modularity, we need to have less or loose coupling. Fine. And our focus should also be to make each module relatively small and simple, and the interactions also need to be simple. The next is abstraction, which you already have talked about. Abstraction, I'll just talk in brief. So it is basically a property where the focus is on the essentials and we try to ignore the finer details. The inner complexity of the module are hidden when you're talking about abstraction. When you're talking about encapsulation, the implementation of a module should be separated from the contractual interface. Here, when you're talking about encapsulation, basically the focus is on information hiding. That means what it happens inside a module is hidden from the outside modules and others cannot see it. So each object's method manage its own attributes and it is hidden from the outside world with respect to the particular software system. And this concept is also known as information hiding. For example, something like this. You have classes, you have methods, which are variables, and these are encapsulated. And from outside, from other objects cannot access and see this. Fine. The other object just looks at this object one, let us say, as a whole with its functionality. The finer details is hidden. Polymorphism, this is a very important property of object-oriented concept. It means the same operation may behave differently on different classes. Like for example, when you're talking about an operation draw. Now, when you're talking about draw operation, which is performed in class circle and class rectangle, class triangle, draw operations, if it is circle, this is a figure, rectangle, this figure leads to, and triangle, this figure leads to this kind of figure. So it is basically the ability of different objects to respond different messages in different ways. So this is a polymorphism, it is the same operation but performing differently based on different classes. Fine. So it is basically the ability to interchange the modules dynamically without affecting the system. Fine. So polymorphism, we can say it allows an object with different internal structures to have a common external interface. They look same but behave differently on the basis of different classes on which it works on. So when you're talking about usefulness of this object-oriented concept, it is being very much used nowadays. It is used for developing different compilers, different object-oriented languages, different complex software system. It is also used as a part of the computer science and software engineering mainstream, and it is used for even handling different languages and applications. It is used by European conferences on OPE and so on. So that much for this concept, for this particular topic. I'll talk more about it in other slides. These are the references which I've referred for this particular topic. That much for now.